You probably already know that if two lines are perpendicular, then the slope of one is the negative reciprocal of the other. I'd like to do a quick and dirty proof of that. So I'm going to start with two lines. One is y equals mx, and the other is y equals nx. The intercepts for both of these are 0, so they both pass through the origin. Now, I'm going to pick 2 points on these lines. The first, the point on y equals mx, is the point 1 comma m. And similarly, on the line y equals nx, I'm going to pick the point 1 comma n. All right, and now I'm going to find the distance between these 2 points. So I'll label this d, and d is equal to the square root of x2 minus x1, which is just 1 minus 1 here, squared, plus y2 minus y1, which is m minus n squared. And that's going to simplify to m minus n. So secondly, I'm going to label the line segment between the origin and 1m a, and between the origin and 1n b. So a is going to equal the square root of 1 minus 0 squared plus m minus 0 squared, which simplifies to the square root of 1 plus m squared. And b is going to equal the square root of 1 minus 0 squared plus n minus 0 squared. And this also simplifies to the square root of 1 plus n squared. Now, because my lines are perpendicular, I have a right triangle. ABD is going to make up a right triangle. So that means that d squared equals a squared plus b squared. So what is d squared? It's this m minus n squared. And a squared and b squared are just what you have under the radical, because the radical and the square will cancel. So this is 1 plus m squared plus 1 plus n squared. So now I just have to expand the left-hand side, and I'm left with m squared minus 2mn plus n squared equals 2 plus m squared plus n squared. And now the m squared will cancel with the m squared, the n squared will cancel with the m squared, and I'll just end up with negative 2mn is equal to 2. And when I divide by negative 2, I'll have m times n is equal to negative 1. So what I'm left with is that m equals negative 1 over n, as desired.